Hello and welcome, this is Majid, and in today's video we will be solving multiple choice question from paper 1 variant 1 of May-June 2020. If you want to go to a particular question, just follow timestamp given in the video description. Let's start. Question 1. Ethene can be oxidized to form epoxy ethane C2H4O. The equation is given. Which sets of conditions give the greatest yield of epoxy ethane at equilibrium? Now this is an equilibrium reaction. Let's find the number of moles. So we have 1 mole of ethane and 0.5 moles of oxygen. They both react together and form 1 mole of product epoxy ethane. So first thing is the effect of pressure on the equilibrium reaction. Now the point is that whenever we increase the pressure, the reaction actually goes from more number of moles to less number of moles. So in this case we have 1.5 moles of the reactants and 1 mole of the product, so therefore the reaction must go in the forward direction. So more product will be formed, or you can say that the greater yield of epoxy ethane is also obtained at higher pressure. So we must use higher pressure. So it could be A or B. Second thing is the temperature. Now as the reaction is exothermic, because the enthalpy change is negative, so for exothermic reaction whenever the temperature is increased, the reaction goes in the backward direction, or you can say that the equilibrium goes backward, or the amount of product decreases. So we must have lower temperature in order to obtain the greater yield at equilibrium. So the answer is part A. Question 2. Cobalt can form the positive ion CONH34Cl2 positive. What is the oxidation number of cobalt in this ion? So let's find out the oxidation state of cobalt. As we know, the formula is CONH3 4 times Cl2 and the overall charge is positive. Cobalt plus ammonia is neutral and there are 4 ammonia molecules, so just 4 multiplied by 0. Chlorine is from group 7, so it has -1 oxidation state. There are 2 chlorine atoms, so 2 into -1, and the overall charge is +1. So cobalt plus 0 minus 2 is equal to +1, or you can say cobalt is equal to +3. So the oxidation state of cobalt is +3, so the answer is C. Question number 3. When considering one molecule of ethene, which row describes both the hybridization? So first thing is we have to find the hybridization of the atomic orbitals in the carbon atoms and the overall bonding. So let's see what is the structure of ethene. The formula of ethene is C2H4 and the structure is like this. Carbon makes a double bond with another carbon atom and it makes single covalent bond with the hydrogen atom. So we can see one of the bond is sigma and the other bond is pi. Similarly, the bond between carbon and hydrogen is also sigma bond. All of them are sigma bonds. First see the hybridization. Now this carbon and this one both are involved in double bond, so therefore whenever carbon is involved in the double bond, then the hybridization is sp2 hybridization. So it could be either A or B. Let's find out the number of sigma bonds. As there are 1, 2, 3, 4, 5 sigma bonds in ethene molecule and 1 pi bond. So the option should be part B. Question 4. 10 cm cube of ethane is burned in 45 cm cube of oxygen at a pressure of 101 kilopascals. This is the normal pressure and a temperature of 200 degrees centigrade. Complete combustion takes place. So whenever complete combustion takes place, it means that the whole of ethane is actually converted into carbon dioxide and water molecules. What is the total volume of gas present when the reaction is complete? So we have to find out the volume of gas present after the reaction is complete. So let's first write the balanced chemical equation for the combustion of ethane. Ethane is C2H6 in the presence of oxygen. It gives carbon dioxide and water. As the temperature that is given is 200 degrees centigrade, it means water molecules are also in the gaseous state. Carbon dioxide is also in the gas, oxygen is in the gas, and ethane is completely burnt. It is also in gaseous form. Let's balance this chemical equation. We have two number of atoms of carbon. Now it is balanced. 6 hydrogen atoms. Balancing hydrogen, 6. Now let's see how many oxygen molecules are in the product. 4 for the carbon dioxide and 3 for water molecules. So 7, we can write 7 by 2 or 3.5. So the ratio of the moles is actually 1 ratio 3.5 between the reactants, and 2 and 3 for the products. This is the mole ratio. We can also write the mole ratio in the volume. So you can also say volume. It could be 1 centimeter cube that reacts with 3.5 centimeter cube to form 2 centimeter cube of carbon dioxide and 3 centimeter cube of water gas. In the question, they have given 10 centimeter cube of ethane and 45 centimeter cube of oxygen. So if there were 10 centimeter cube of ethane, then according to the ratio 1 ratio 3.5, there must be 35 centimeter cube of oxygen, which is completely required for the complete combustion of ethane. And 20 centimeter cube of carbon dioxide is formed along with 30 centimeter cube of water. But the amount of oxygen given in the question is actually 45 centimeter cube. So it means that out of this 45 centimeter cube, only 35 centimeter cube is required for the combustion. The volume that is left behind is actually 10 centimeter cube. So whenever there is complete combustion, there is no more ethane. 35 centimeter cube of oxygen is gone. So out of 45, we just have 10 centimeter cube left. Volume of carbon dioxide formed is 20. Volume of water molecules formed is 30. So after this chemical reaction, we have these 3 volumes present with us. So let's just add them up, 30 and 20 and 10. We have 60 centimeter cube. This is the total volume of gas that is present after the chemical reaction. So the answer is part D. Question number 5. 2 reactions are shown. Hydrogen gas converts into hydrogen atoms. Carbon monoxide converts into carbon dioxide gas. If molar amounts are used, how can the 2 energy changes associated with these reactions be described? So let's see what are the energy changes associated with these equations. A. Enthalpy change of atomization and enthalpy change of combustion. Atomization is actually when 1 mole of atoms is formed from the elements in the standard state. So in this equation, actually 2 moles of hydrogen atoms are being formed. So this is not the standard enthalpy of atomization. And enthalpy of combustion is when some substance is burnt in excess of oxygen to form the product. So in this equation, carbon monoxide is being combusted in the presence of oxygen to give carbon dioxide. So yes, it is enthalpy of combustion. Part B. Enthalpy of atomization. Again, this is wrong. And enthalpy of formation. Enthalpy of formation is actually when 1 mole of a compound is formed from the elements in their standard states. In this equation, carbon monoxide is not an element. There should be actually carbon in the solid state. Then this was correct. So this is also wrong. C. Bond energy and enthalpy of combustion. Bond energy is something when a covalent bond is broken into its atoms. So yes, hydrogen gas is being converted into hydrogen atoms. So actually hydrogen bonds is being broken and it forms 2 hydrogen atoms. Enthalpy of combustion, it is correct as we already studied. So it could be part C. Part D says bond energy is correct for hydrogen, and enthalpy of formation. Now this is not enthalpy of formation because the elements are not in their standard states. So the only option is part C, and that is the answer. Question 6. The diagram shows the Boltzmann energy distribution curves for molecules of sample of a gas at two different temperatures. Which letter on the axis represents the most probable energy for molecules of the same sample of gas at the lower temperature? So lower temperature actually means the number of molecules will have lower energy. Now in Boltzmann distribution we have y-axis and x-axis. X-axis actually shows the energy of molecules. And y-axis shows the number of molecules. Now when the temperature will be lower, it means that the energy of molecules will be less, so it will be C rather than D. And when the energy is C, it means that the number of molecules with lower energy are greater in number as compared to the number of molecules having higher energy. So the only option is C. Question 7. What are the units of Kp for the reaction shown? In this reaction, water gas reacts with carbon solid to give hydrogen gas and carbon monoxide gas. Let's find out the units of Kp. Now in this reaction, we know that water molecule is in gaseous form, carbon is in solid form. For the solid reactant, we cannot take the unit for Kp. It is only for gaseous ones. So writing the formula of Kp, Kp is equal to pressure of hydrogen multiplied by pressure of carbon monoxide divided by pressure of water gas. As we know that the unit of pressure is actually pascals, so it will be Pascal into Pascal divided by Pascal. So the answer should be pascals. So the unit is pascals and the answer is part B. Question 8. In this question you should use changes in oxidation numbers to balance a chemical equation. Acidified potassium dichromate solution can oxidize a solution of V+2 ions. The equation for this reaction is shown. What is the ratio A, B in the correctly balanced equation? Now let's first find out the oxidation state of chromium in the reactant side and the product side. So on the reactant side we have Cr2O7 - 2. There are 2 chromium atoms plus there are 7 oxygen atoms. Each oxygen has a charge of -2 and the overall charge is also -2. 2 chromium minus 14 is equal to, or you can say 2 chromium is equal to plus 12 and each chromium will be plus 6. So the charge on one chromium atom is plus 6 on the reactant side and the charge is plus 3 on the product side. Now going from plus 6 to plus 3, the oxidation state is reduced, so it means it is reduction. Vanadium is in plus 2 oxidation state on the reactant side, and in the product side we can find the oxidation state V plus there are 3 oxygen atoms, so -6 for oxygen and overall charge is -1. So vanadium is plus 6 minus 1, so it will be plus 5. So it goes from plus 2 to plus 5, that is oxidation. Now there are several steps to balance the redox reactions. First one is to write the half equations. One of the half equation is of reduction and second one is of oxidation. So let's write the reduction first. Cr2O7 minus 2, it goes into Cr plus 3. Now the oxidation equation is V plus 2 and it converts into VO3 minus. Now the second step is to balance the atoms other than oxygen atom and hydrogen atom. There are 2 chromium on the reactant side, so just balancing chromium, and vanadium is also balanced. Now balance the number of oxygen atoms by adding water molecules on the opposite side. With Cr2O7 there are 7 oxygen atoms, so we have to add 7 water molecules on the product side in order to balance the oxygen atoms. Similarly, for the oxidation equation, we can add 3 water molecules to the reactant side in order to balance the number of oxygens. Now we can balance the number of hydrogen atoms by adding H plus ions on the opposite side of the equation. For the first equation, reduction equation, we have 14 hydrogen atoms on the product side, so we can add 14 H plus ions to the reactant side. Similarly, we can add 6 H plus ions in order to balance the number of hydrogen atoms in this equation. Now another step is to balance the charges by adding electrons on either side of the equation. We have plus 14 charge minus 2 charge, so the overall charge is plus 12 on the reactant side. We have plus 6 charge on the product side. So we can reduce the charge by adding electrons. So we can add 6 electrons to the reactant side, so it will become plus 6. Similarly, calculating the charges in the second equation, we have plus 2 charge and minus 1 and plus 6. So the overall charge is plus 5 on the product side and plus 2 on the reactant side. It means we can add 3 electrons to the product side in order to balance the charges. Now next step is to balance the number of electrons. In both equations, we have 6 electrons in the first equation and 3 electrons in the second equation. So the second equation must be multiplied by 2 in order to equalize the number of electrons lost and the number of electrons gained. Now rewriting the chemical equations, 14H plus Cr2O7 minus 2 plus 6 electrons gives 2 Cr plus 3 plus 7 water molecules, and the second equation is 6 H2O plus 2 V plus 2 ions, 2 VO3 minus ions, and 12 H plus ions. Combining the two equations, we can get 14H plus Cr2O7 minus 2 plus 6 water molecules plus 2 V plus 2, and it gives 2 Cr plus 3, 2 VO3 minus, 7 water molecules, and 12 protons. I haven't written the number of electrons because the number of electrons lost and gained will cancel out each other. Now in the question they have asked about the ratio A ratio B, which is between Cr2O7 and V plus 2. So we can find this Cr2O7 and V plus 2, the ratio comes to be 1:2, and therefore the answer is B. Question 9. A sample of argon has a mass of 0.2 grams at a pressure of 100,000 pascals and a temperature of 12 degrees centigrade. Which volume does the gas occupy? So they have given you the mass and the pressure and the temperature. So we can write the gas equation. PV is equal to nRT. Now let's convert the given values into the required ones. First one is 0.2 grams. Now the atomic mass of argon is 39.9. So the number of moles will be moles is equal to mass divided by atomic mass. So it will be 0.005 moles. The pressure is 100,000 pascals. The unit of pressure will not be changed. It will be in pascals. Third thing is the temperature. So we can change the temperature to Kelvin by just adding 273. So it becomes 285 Kelvin. Now in order to find the volume, we can rewrite the chemical equation as V is equal to nRT divided by pressure. Just putting the values, N is the number of moles. We have 0.005 mole. The value of R is 8.31. Temperature is 285 Kelvin. The pressure is 100,000 pascals. The unit of volume is meter cube. So volume will be 0.000119 meter cube. Converting it into centimeter cube, we just have to multiply it by exponential 6. So the answer comes to be 119 centimeter cube. So the answer is part D. Question 10. In which pair does each species have the same number of unpaired electrons? We just have to find out the number of unpaired electrons. So for that we will have to do the electronic configuration of each element. Let's find the number of protons of each element. Aluminum has 13 atomic number. Copper has 29. The atomic number of calcium is 20. Chromium is 24. Calcium is 20 again. Nickel is 28. Iron is 26. And oxygen is 8. Now first solving part A. We have aluminum. Atomic number is 13, so there are 13 electrons. The electronic configuration will be 1s2, 2s2, and 2p, 6, 3s2, 3p1. So there is just one unpaired electron present in the p orbital. Let's find out copper plus 2. The atomic number is 29, so the number of electrons are actually 27 because the charge is plus 2, 2 electrons are lost. Writing the electronic configuration: 1s2, 2s2, 2p6, 3s2, 3p6, 4s1, and 3d10. This electronic configuration is for neutral copper, as we know that the charge is plus 2, so 2 electrons will be lost. First electron is going to be lost from 4s orbital and 1 goes from d orbital. So the electronic configuration becomes 4s0, 3d9. Now d orbital is further made up of 5 suborbitals. 1, 2, 3, 4, 5, 6, 7, 8, 9. So just one unpaired electron is left. It means that the number of unpaired electrons in both aluminum and copper plus 2 is the same. So part A is correct. Let's move to the part B. Part B is calcium and chromium plus 3. First, the electronic configuration of calcium. We can write it from starting from argon, as we know that the atomic number of argon is 18. And 2 electrons are left, which is 4s2. So the total electrons will be 20. There is no unpaired electron in calcium. Now let's find out about chromium. The atomic number is 24. So it means there are 21 electrons present in the chromium ion. The electronic configuration will be argon 18. Then we have 4s 0 and 3d 3. Now the number of electrons present in the 3d orbital are like this. So we have 3 unpaired electrons present in chromium plus 3 ion. Calcium has 0 unpaired electrons and chromium has 3, so this is not the answer. Let's move to the part C now. In part C we have calcium. Again, there are no unpaired electrons. And nickel plus 2. So let's do the electronic configuration of nickel plus 2. The atomic number is 28 and the number of electrons are 26. So the electronic configuration could be written as argon 18. Then we have 4s 0 and 3d 8. One, 2, 3, 4, 5, 6, 7, 8. So there are 2 unpaired electrons present in the d orbital. So nickel has 2 and calcium has none. Now finding the number of unpaired electrons in part D, we have iron plus 3. The atomic number is 26. So the number of electrons are 23. Electronic configuration will be argon 18, 4s 0 and 3d 5. So we have 5 unpaired electrons present in the ion of iron plus 3. Now oxygen atom, we have -2 charge, atomic number is 8, so there are 10 electrons and the electronic configuration will be 1s2, 2s2, 2p6. So there is no unpaired electron present in oxygen ion. So the only answer is part A. Question number 11. A sample of solid ammonium chloride decomposes on heating. We have decomposition reaction. Solid ammonium chloride converts into ammonia gas and hydrogen chloride gas. A total of 2.4 exponential 21 molecules of gas is formed. How many hydrogen atoms are present in the gaseous products? They have given a total of 2.4 exponential 21 molecules which are of both ammonia gas and hydrogen chloride gas. Let's write the chemical equation. Ammonium chloride, it converts into NH3 and HCl. Now this equation is balanced. It means 1 mole of ammonium chloride converts into 1 mole of ammonia and 1 mole of HCl. As we have equal number of moles of products, so it means the number of molecules will also be equal among them. As the total of 2.4 exponential 21 molecules is formed, so then dividing that by 2, 2.4 exponential 21 divided by 2, we have 1.2 exponential 21 molecules for each ammonia and HCl. So ammonia is 1.2 exponential 21 molecules. HCl is also 1.2 exponential 21 molecules. Now in the question they have asked about the number of hydrogen atoms, not the molecules. So let's just find the number of hydrogen atoms in ammonia first, and then we are going to find number of hydrogen atoms in HCl. As we know that 1 molecule of ammonia means 3 atoms of hydrogen. Because in 1 molecule of ammonia there is 1 nitrogen atom and 3 hydrogen atom. So in 1.2 exponential 21 molecules of ammonia, we will have 3 into 1.2 exponential 21 atoms of hydrogen. So the answer is 3.6 exponential 21 atoms of hydrogen. This is present in the molecule of ammonia. Now let's do the same thing for HCl. We know one molecule of HCl has one atom of hydrogen. So similarly, 1.2 exponential 21 molecules of HCl will have 1.2 exponential 21 atoms of hydrogen. Now combining the total number of hydrogen atoms present in both ammonia and HCl, we have 3.6 exponential 21 plus 1.2 exponential 21. Now the total number of hydrogen atom is 4.8 exponential 21. So the answer is part C. Question 12. A white powder of mixture of sodium chloride and sodium iodide. It is dissolved in water in a test tube. An excess of aqueous silver nitrate is added to the test tube. A precipitate X is observed. An excess of concentrated ammonia is then added to the test tube containing X. After the test tube has been shaken, a precipitate Y is observed. Which statement about X or Y is correct? Now let's write the chemical equation for this. We have silver nitrate added to the test tube of sodium chloride and sodium iodide. So the product precipitate could be silver chloride solid or silver iodide. Silver chloride precipitate is white in color, while silver iodide is yellow. When concentrated ammonia is added to both of them, what happens that in the presence of concentrated ammonia, AgCl dissolves, while in the presence of concentrated ammonia, silver iodide is insoluble. It means that the resulting color should be yellow. Now A says X is pure white in color. No, X should be silvery white because X is silver chloride. So this is wrong. X is silver iodide. No, it is silver chloride. Y is pure silver chloride. No, Y is silver iodide. Y is yellow. So the only option that is correct is D. Question 13. 6.90 grams of an ammonium salt is heated with an excess of aqueous sodium hydroxide. The volume of ammonia produced measured under room conditions is 2.1 decimeter cube. Which ammonium salt is used? So they have given us 4 different types of salts: ammonium carbonate, ammonium chloride, ammonium nitrate, and ammonium sulfate. These salts are heated in the presence of sodium hydroxide, so we have NaOH, and gives ammonia as a product. Along with the sodium salt and water. Now in the question they have given the volume of ammonia to be 2.51 decimeter cube measured under room conditions. So we can find the number of moles of ammonia. 2.51 divided by 24 decimeter cube. Now the number of moles will be 0.104 mole. Now there are 2 types of ammonium salts. One is having 2 number of nitrogen atoms and the other one is having 1 number of nitrogen atoms in its compound. This one also has 1 and this one has 2 number of nitrogen atoms. If ammonium carbonate was there, so it means we can balance ammonium carbonate with ammonia in 1:2. Now the number of nitrogen atoms will be balanced. It means that the number of moles of ammonium carbonate should be half of 0.104, and the half of 0.104 is actually 0.052 mole. Now we can find the individual moles of all these 4 salts. The atomic masses are 96 for ammonium carbonate, 53.5 for ammonium chloride, 80 for ammonium nitrate, and 132.1 for ammonium sulfate. So the number of moles will be 0.071, 0.128, 0.086, and 0.052. Now we can also find the ratio between rest of the given salts and ammonia. If it is ammonium sulfate, so we also have the ratio 1:2 in order to balance the number of nitrogen atoms. So the number of moles should be half, and the answer should be 0.052 moles. And yes, D is the possible answer. While for part B and C, the number of moles of ammonium chloride and ammonia should be equal because the molar ratio is 1:1. Same is for ammonium nitrate, we have 1:1, so the number of moles of the reactant should be 0.104, which is not given. So the only answer is part D, which is ammonium sulfate. Question 14. An excess of magnesium oxide is shaken with water. The resulting mixture is filtered into test tube P. An excess of barium oxide is shaken in with water, and the resulting mixture is filtered into test tube Q. So we have 2 test tubes. One is of magnesium oxide with water, second is of barium oxide with water. Which oxide reacts more readily with water and which filtrate has the lower pH? So for group 2 oxides, we know that beryllium oxide, then we have magnesium oxide, then calcium oxide, then barium oxide. As we know that the reactivity of oxides increases down the group with water. So the reactivity increases. It means that barium oxide is more reactive than magnesium oxide. So it should be A or B. Now let's find out the solubility of group 2 hydroxides. Now for group 2 hydroxides, we know that the solubility of hydroxides down the group increases. So it means that barium oxide is more soluble in water as compared to beryllium hydroxide or magnesium hydroxide. So test tube P is of magnesium hydroxide and test tube Q is of barium hydroxide. Barium hydroxide is more alkaline, so it means it will have higher pH. And the question says test tube with filtrate of lower pH. So the one with lower pH should be P. So the answer is part A. Question number 15. Element Z has a giant structure. The chloride of Z reacts with water to give a solution with a pH less than 5. It means that the chloride is acidic in nature. Which pair shows 2 elements which could be Z? So we have to find out the element having giant structure and acidic chloride. A says aluminum and magnesium. Now aluminum is a metal, so therefore it has giant structure. Similarly, magnesium is also a metal, so it has a giant structure. Again, aluminum has a giant structure and silicon has giant covalent structure. Phosphorus does not have a giant structure. Magnesium does have. Similarly, not phosphorus, but silicon is true. So we have 2 options, either A or B. So we can find out whether which chloride is acidic in nature. So let's just find out aluminum chloride. aluminum chloride plus water gives aluminum hydroxide along with HCl, and the pH of solution is acidic. For magnesium chloride, MgCl2 reacts with water to give magnesium hydroxide and HCl. The pH of this solution is nearly equal to 6, so it is weakly acidic. Third one is silicon chloride SiCl4. It reacts with water to give silicon oxide and HCl. So the solution of silicon chloride in water is also acidic in nature. So the most probable answer is B. Question 16. Sodium, aluminum and silicon are three elements in period 3. Each element forms an oxide. Which row has three correct properties of these oxides? Sodium oxide. Now sodium oxide is a metal oxide and it is basic in nature. Sodium oxide, the bonding is ionic, so it is giant ionic structure. The melting point is also very high for the ionic compounds. And the reactivity with water is, yes, it is reactive and it forms alkaline solution of sodium hydroxide. For aluminum oxide, we know that it is amphoteric in nature, so this is wrong. It is giant ionic, yes, because it is an ionic compound with aluminum ions and oxide ions. The melting point is also very high, so this is wrong. And there is no reaction with water because it is insoluble. So this is true. Third one is silicon dioxide. It is acidic in nature, not amphoteric. It is simple molecular. This is wrong because it is giant covalent compound. It has a high melting point. This is true. And it also does not react with water. So the correct option seems to be D. Question 17. 0.25 grams of anhydrous magnesium nitrate is heated strongly until it completely decomposes. What is the total volume of gas produced measured under room conditions? Let's write the balanced chemical equation for this decomposition. We have magnesium nitrate. It decomposes into magnesium oxide, nitrogen dioxide, and oxygen gas. Balancing this chemical equation, we can write 2 moles of magnesium nitrate, 2 moles of magnesium oxide, 4 moles of NO2 and 1 mole of oxygen. Now this equation is balanced. As magnesium oxide is solid, NO2 is gas, oxygen is gas, so we'll only consider nitrogen dioxide and oxygen gas for this question. Now the molar ratio is 2 for the reactant, 4 for nitrogen dioxide and 1 for oxygen atoms. It means when 2 moles of magnesium carbonate is decomposed, it forms 4 moles of NO2 and 1 mole of oxygen. So let's first find out the number of moles of magnesium nitrate given in the question. We have 0.25 grams and the molecular mass of magnesium nitrate is 148. So we can find the number of moles. 0.25 divided by 148, it is 0.0017. So if 2 moles of magnesium nitrate forms 4 moles of magnesium oxide, then 0.0017 moles of magnesium nitrate will form 2 into 0.0017 moles of NO2 and 0.0017 divided by 2 moles of oxygen, because the ratio is half for oxygen and double for NO2. So let's just find the number of moles. So it is 0.0034 moles of NO2 and 0.00084 moles of oxygen. Now we can find the volume of gas by multiplying it by 24,000 centimeter cube actually. So the volume comes to be 81 centimeter cube for NO2 and 20 centimeter cube for oxygen. So the total volume will be 81 plus 20, 101 centimeter cube. So this is the volume of gases that is formed by decomposing 0.25 grams of magnesium nitrate. So the answer is part C. Question number 18. Astatine is below iodine in group 17 of the periodic table. Which statement is most likely to be correct? A. Silver acetate reacts with an excess of dilute aqueous ammonia to form a solution of soluble complex. Now this statement is wrong because only silver chloride is dissolved in aqueous ammonia to form a soluble solution. Silver acetate does not dissolve in dilute aqueous ammonia. Astatine and KCl react to form potassium acetate and chlorine. Now astatine cannot displace chloride ion because astatine is below in the 7 group. So the member below in the series cannot displace the member above it. This is true for halogens. So this is wrong. Actually chlorine can displace astatine but astatine cannot displace chlorine. Part C. Potassium acetate and dilute sulfuric acid react to form hydrogen acetate. Now this is also wrong because potassium acetate cannot react with dilute sulfuric acid. Instead, we need concentrated sulfuric acid for this reaction. D. Sodium acetate and concentrated sulfuric acid react to form astatine. Now this is correct. The equation for this chemical reaction would be like this. Sodium acetate plus sulfuric acid. It forms sodium hydrogen sulfate along with hydrogen acetate gas. The hydrogen acetate also reacts with sulfuric acid to form astatine molecule, hydrogen sulfide and water. So part D seems to be the right answer. Question 19. What is the order of increasing melting point of these 3 chlorides shown? First one is carbon tetrachloride, second is magnesium chloride and third is phosphorus pentachloride. Now carbon tetrachloride is a gas at room temperature, so its melting point is very low. Magnesium chloride is giant ionic structure, so it has a quite high melting point. PCl5 is also solid at room temperature, but the melting point is lower as compared to magnesium chloride because the attraction between the ions is not as strong as magnesium chloride. The respective melting point is minus 22.9 for carbon tetrachloride, 714 degrees centigrade for magnesium chloride, and 160.5 degrees centigrade for phosphorus chloride. So the lowest melting point is of carbon tetrachloride and the highest is of magnesium chloride. So the answer is A. Question 20. The skeletal formula of compound X is shown. Which row is correct? Molecular formula of X we have to find the molecular formula. So we can find that by counting the number of carbon and hydrogen atoms. 1, 2, 3, 4, 5, 6, 7. So we have 7 carbon atoms. There are 3 hydrogen atoms in the corners. 1 with this carbon, 2 with this carbon, 2 with this carbon, 3 with this carbon. So hydrogens are 14 and there is just a single oxygen, so it is C7H14O. So it could be either A or B. Now next thing is the observation on addition of X to Fehling's reagent. We know that Fehling's reagent gives a positive results with aldehydes and it does not give a precipitate with ketones. In the structure of X, we have carbonyl carbon and this group is ketone group. So therefore there will be no change on the addition of Fehling's reagent. So the answer is part A. Question 21. Which statement is correct? 2,2-dimethylpropanoic acid is an isomer of propyl methanoate. 2-methyl-butane-2-ol is an isomer of hexane 3-ol. So this is the question about isomers. So just let's find out part A. We have 2,2-dimethylpropanoic acid. On second carbon we have 2 methyl groups, so it will be CH3, CH3, CH3 and COOH. Propyl methanoate will be HC double bond O O C C C. We have the carboxylic acid of 1 carbon atom and alcohol of 3 carbon atoms. Now the number of carbon atoms are 1, 2, 3, 4, 5. 5 for this one and 4 for this one. So these are not the isomers because the number of atoms are not equal. So let's move to part B. We have 2-methyl-butane-2-ol. So on second carbon we have methyl group and also alcohol group. Number of hydrogens will be 3, 3, 2 and 3. Hexane 3-ol will be 6 carbon atoms. And on third carbon we have alcohol group. Hydrogens will be H3, 2, 2, H, 2, 3. Now we can count the number of atoms. We have 5 carbons in this one and 6 carbons in this one. So this is also not the example of polymer. So both A and B are wrong. Let's see part C. In part C we have 3-methyl-butane-2-one. This is a ketone with 4 number of carbon atoms in the long chain. Carbonyl carbon is on second carbon and methyl group is on third carbon. Now the number of hydrogens 3, 3, 1 and 3. Pentanal means we have 5 carbon atoms and as it is an aldehyde, so the carbonyl carbon is on the last carbon. Now 3 hydrogen with this 2, 2, 2. Now we can count the number of atoms. We have 5 carbons, 10 hydrogen atoms, 1 oxygen atom. For this we have 5 carbons, 10 hydrogen atoms and 1 oxygen atom. So yes, they are the isomers of each other. So this could be the possible answer. Now part D, we have 3,3-dimethyl-butane-2-one. So we have 4 carbon atom and on the second carbon we have ketone and on the third carbon we have 2 methyl groups. Now balancing with hydrogens. Pentane 3-one we have 5 carbon atoms, and on third carbon we have carbonyl group, so it is a ketone. Counting the number of carbons, we have 6 carbons, 12 hydrogen atoms, 1 oxygen atom. We have 5 carbons, so therefore they are not the isomers. So the only option is C. Question number 22. But1-ene and but2-ene are treated separately with cold dilute acidified manganate ions. 4 students make statements about these alkenes and the diols formed from them. So first, let's find out the structure of but1-ene. We have double bond on the first carbon atom, and rest are the hydrogens. For but2-ene, we can draw the double bond is on second carbon atom, both of these react to form diols. So the diol formed will be like this: OH group on this carbon atom and OH group on this carbon atom, and the double bond is converted into single bond like this. And with the but2-ene we have oxygen atom and oxygen atom, and also double bond is converted into single covalent bond. So we have 2 different types of diols. Now primary alcohol and secondary alcohol can be described as this. Primary alcohol means that the carbon attached with the OH group is further attached to only one carbon atom directly, while the secondary alcohol means that the carbon atom directly attached with the OH group must be attached with 2 carbon atoms. So this one is primary and this one is secondary alcohol. W says one diol contains 2 primary alcohol groups. So we have this one as primary alcohol, and this is not primary, this is secondary alcohol. In the second compound we have secondary alcohol and secondary alcohol. So this is wrong. X says one diol contains a primary and a secondary alcohol group. So this is correct because the first but1-ene consists of a primary alcohol group and also a secondary alcohol group, because this carbon is further connected directly to 2 carbon atoms. So this is correct. Y says one diol contains 2 secondary alcohol groups. This is true for but2-ene because we have 2 secondary alcohol groups attached. So this is also correct. And Z says both alkenes exhibit cis-trans isomerism. So but1-ene does not exhibit cis-trans isomerism because double bonded carbon has 2 similar hydrogen atoms attached with it. I can draw it again. Now you can see that this double bonded carbon has 2 similar atoms, so this cannot have a cis-trans isomerism. So this is wrong. So the answer is part C. Question 23. 2-bromo-2-methylpentane is a tertiary halogenoalkane. Which organic products are formed when 2-bromo-2-methylpentane reacts with hot concentrated ethanolic solution of sodium hydroxide? Now we know that the hot concentrated ethanolic solution of sodium hydroxide causes elimination reaction. Let's draw the structure of 2-bromo-2-methylpentane first. We have a long chain of 5 carbon atoms. On second carbon we have bromo and methyl group, and rest is alkane. Now when this compound is reacted with hot concentrated ethanolic sodium hydroxide, then HBr is eliminated. From one carbon we have bromine atom which is lost, and then from adjacent carbon we would have hydrogen atom. So the adjacent carbon could be this one, it could be this one, or it could be this one. So we have three types of structures. Now let's draw each one. The first double bond could be between this. The second double bond could be between these two carbon atoms. And the third double bond could be between these two carbon atoms. Now naming these compounds, we have one, two, three, four, five. So 2-methyl 1-pentene, or you can say 2-methyl pent 1-ene. For second, we have this compound, and the name is 1, 2, 3, 4, 5. So it is also 2-methyl pent 1-ene. So both of these are the same. Actually, this is one type of compound. Naming the third one, we have one, two, three, four, five. So methyl group is on second carbon. We have 2-methyl pent 2-ene. So the answers is 2-methyl pent 1-ene only. This is wrong. 2-methyl pent 1-ene and 2-methyl pent 2-ene. Yes, because we have two different types of molecules being formed. 2-methyl pent 2-ene only, 2-methyl pent 2-ene, and 4-methyl pent 2-ene. This is wrong. So the only answer is part B. Question 24. Polypropene is an addition polymer. What are the CCC bond angles along its polymer chain? So we know that the monomer is like this. We have double bond present between two carbon atoms, and rest is the number of hydrogens. So when a polymer is formed, it will be like this. This will be the repeat unit. So in the polymer, we can see that the central carbon atom is attached with the other elements with single sigma bonds. So there are 4 covalent bonds around the carbon atom. So the structure is tetrahedral, and for tetrahedral the bond angles are 109 degrees. So A, they are all 109, yes, and there is no 120 degree, no 180 degree, no 120 degree. So the only answer is part A. Question 25. An alcohol has the molecular formula C5H12O. It has several isomers. Which isomer forms a yellow precipitate with alkaline aqueous iodine? So we know that the only alcohol that can form precipitate with aqueous iodine is CH3COH. This type of alcohol can always give positive result with aqueous iodine. Now let's see among these 4 which one has this type of alcohol compound present. The structure of 2,2-dimethyl-propane 1-ol will be like this. We have propane. On first carbon we have alcohol group. On second carbon we have methyl and again methyl group. So this is 2,2-dimethyl-propane 1-ol. Now you can see there is no methyl group attached with this carbon atom as was in this case. So this cannot give a yellow precipitate. B is 2-methyl-butane 2-ol. So let's draw the structure first. As you can see, with the alcoholic carbon atom, we have 3 carbon atoms directly attached. So this is tertiary alcohol, and tertiary alcohol does not give positive result with aqueous iodine. Only secondary alcohol can give positive result with aqueous iodine. So this is wrong. Now drawing part 3. We have 3-methyl butane 2-ol. On second carbon we have alcohol, and on third carbon we have methyl group. Now in this compound you can see that the carbon atom directly attached with the OH group has one methyl group attached, and it is secondary alcohol, so it will give positive result with aqueous iodine. Last one is pentane 3-ol. We have 5 carbon atoms, and on third carbon atom we have alcohol group. As you can see, there is no methyl group directly attached with this carbon atom, so therefore this does not give positive result. So the only option is part C. Question 26. When compound X is heated under reflux with aqueous sodium hydroxide solution, 2 products are formed, sodium ethanoate and hexane 1-ol. From these products you can find out that the reactant was ester. What is compound X? So we can see A, B, C, D. All of them are esters. So ester is like this. Whenever sodium hydroxide is added, so what happens that this bond is broken, and with oxygen sodium atom makes a bond, and with R alcohol group combines. So let's just find out how these compounds will be broken. In A, the bond is broken on this side, and we have sodium atom here and OH on this carbon. B will be broken from this place. We have sodium atom with oxygen and alcohol group with this carbon. C, this bond will be broken. We have sodium atom with oxygen and alcohol group. Similarly for D, so the question says sodium ethanoate and hexane 1-ol is formed. Hexane 1-ol means there are 6 carbon atoms and alcohol is attached to the first carbon. So let's find out hexane 1-ol. In A we have 2 carbon atoms with alcohol, so it is ethanol. This is not hexane 1-ol, so therefore A is wrong. In B we have 1, 2, 3, 4, 5, 6, 7 carbon atom with alcohol, so this is also wrong. In C we have 1, 2 carbon atoms with alcohol, so this is also wrong. In D we have 1, 2, 3, 4, 5, 6 and OH group. So D seems to be correct because it makes hexane 1-ol, and the other compound is sodium ethanoate. So we have 2 carbon atoms, 1, 2, and we have sodium ion, so it is sodium ethanoate and hexane 1-ol. So therefore answer is part D. Question 27. What is the major product Z of the following reaction? We have an alkene which reacts with excess of dry HBr and forms Z. Now we know that according to Markovnikov addition, the hydrogen of incoming HBr will be attached with the carbon atom present in the double bond, and the carbon atom having more number of hydrogen atoms will be preferred for hydrogen, and the carbon atom with less number of hydrogen will be preferred for bromine atom. So let's first find out the number of hydrogens with each doubly bonded carbon atom. This carbon has just 4 bonds, so it has no hydrogen atom, so it means bromine will be attached to this one. This carbon atom has 3 bonds, so it has 1 hydrogen atom. This carbon has already 4 bonds, so no hydrogen atom for this one. And this one is making 2 bonds, so it has 2 hydrogen atoms. So now, according to Markovnikov of addition, HBr will be added as follows. We have this compound. The incoming hydrogen will come over here and there will be 3 hydrogen atoms and the bromine will be attached to this part. Similarly, there will be 2 hydrogen atoms on this carbon atom and bromine is attached to this part. So the similar structure is B. Question 28. The structure of compound Q is shown. This is compound Q. How many chiral centers are present in the molecule of Q? So for chiral carbon, we know that the carbon that is bonded with 4 different groups. Let's find out the chiral centers. For carbon atom, you must know that for carbon atom to be chiral, there must be no hydrogen atom with carbon or just 1 hydrogen atom should be present. And there should be no double bond with that carbon. If a carbon justifies these 3 points, then it could be chiral. Now let's find out. Starting from this carbon, we have 2 hydrogen atoms, so this is not chiral. This carbon atom has 2 hydrogen atoms, so it is not chiral. This one has 2 hydrogen atoms, so it is not chiral. This one has no hydrogen atom, but it has 2 methyl groups attached, so it is also not chiral. Similarly, this has 3 hydrogen atoms, this has 3 hydrogen atoms, this one has 2 hydrogen atoms. Now this carbon is bonded to no hydrogen atom and there are 4 different groups attached. One is this one is this one is methyl group, and one is this whole compound. So this carbon is chiral. This one is not. This one has just 1 hydrogen atom and there are other 3 different groups. So this is also chiral. This one is not chiral because it has 2 hydrogen, not chiral because it has 2 hydrogen atoms. This could be chiral. It has got 1 hydrogen atom and 1, 2, 3 different groups attached. So this is also chiral. This carbon atom is attached to 1 hydrogen atom and 1, 2, 3 different groups. So this is also chiral. Similarly, this carbon atom is attached to 1 hydrogen atom and 3 other groups, so it is also chiral. This carbon atom has 2 hydrogen atoms, so it is not chiral. This carbon has 1 hydrogen atom and 3 different groups, so it is also chiral. This carbon also has 1 hydrogen atom and 3 different groups, so it is also chiral. This carbon has got double bond, so it is not chiral. This one has 2 hydrogen atoms. This one has double bond. This one has 2 hydrogen atoms. This one has 3 hydrogen atoms. This one has 3 hydrogen atoms. And this one got 2 methyl groups attached. So they are the same groups. So this is also not chiral. So we can find out that 1, 2, 3, 4, 5, 6, 7. So we have 7 chiral centers present in the molecule of Q. So the answer is 7. Question number 29. Compound X has the infrared spectrum shown. What could be the identity of compound X? Now we can see in this spectra there are two important peaks. One is this one, and the second is this broad peak. Let's find out what is the identity of this compound. A is ethanoic acid. So we know that in ethanoic acid we have carbonyl carbon and OH group attached. So from data booklet we come to know that carbonyl carbon of carboxylic acid, its value is between 1680 and 1730 per centimeter, while OH group of carboxylic acid, it gives a broader peak at 2500 to 3000 per centimeter. So this graph looks like as if it is of ethanoic acid, because both of the peaks are present. One is sharp peak between 1680 to 1730. This is 1700, this is 1600. And another one is sharp and broad peak between 25 and 30. 2500 and 3000. Part B is ethanol. The functional group in ethanol is OH, and OH functional group absorbs between 3200 to 3600 per centimeter, but the peak is sharp. So there is no sharp peak between 32 and 3600, so it is not ethanol. Then we have ethyl ethanoate, which is an ester. And in ester we know that we have carbonyl carbon and also carbon bonded with oxygen. Now the carbonyl carbon of ester gives the peak between 1710 to 1750, which is a sharp peak. D is propanone. Propanone also has carbonyl carbon because it is a ketone, and it also gives the peak between 1670 to 1740. The peak is sharp. Now we know that this peak is present, this one is also present, but both C and D does not give the broader peak value. So the broader peak value only comes from ethanoic acid, so therefore the answer is part A. Question 30. Which reaction produces an organic anion with a good yield? A is heating ethane nitrile under reflux with dilute sodium hydroxide. So let's see how this reaction goes. We have ethane nitrile. It reacts with sodium hydroxide, aqueous, under reflux. The product is sodium salt of carboxylic acid, ethanoic acid basically, along with ammonia gas. Now we know that sodium salt of carboxylic acid or sodium ethanoate is quite soluble in water, so it will produce quite high quantity of ethanoate ions, and it is an organic anion. Now let's see part B. Heating ethane nitrile under reflux with dilute sulfuric acid. If we reflux the same compound with dilute sulfuric acid, under reflux, then we have ethanoic acid along with ammonium salt. In this case the acid is sulfuric acid, so the ammonium salt is sulfate. Now we know that acetic acid also ionizes to give ethanoate ion and H positive ion, but ethanoic acid is weakly ionized into ethanoate ion and H positive ion. So the number of ions are lesser as compared to number of ions produced by the first equation. Now going to the part C, we have heating ethane with sodium metal. This reaction does not occur. Now moving to part D, heating ethanol under reflux with dilute sodium hydroxide. So this reaction also doesn't occur. So the only possible answer is part A. Question 31. Which terms can be illustrated by an equation that includes the formation of a positive ion? Number 1 is first ionization energy. We know that ionization energy is actually the amount of energy required to remove an electron from the isolated gaseous atom. So it converts any neutral atom into ion. So a positive ion is formed by first ionization energy. This is true. Second is heterolytic fission of a covalent bond. We know that when heterolytic fission takes place, there is unequal distribution of electrons. So one of the element becomes positive and the second element becomes negative ion. So there is the formation of a positive ion. So therefore this is also correct. Third is enthalpy change of atomization. In enthalpy change of atomization, 1 mole of atoms is formed from the elements. So no ion is formed, therefore this is not the one. So we just have two options, 1 and 2, which are correct. So therefore the answer is B. Now question 32. Which molecules have no overall dipole moment? First is boron trifluoride, BF3. Now BF3 has trigonal structure in which boron does not have any lone pair of electrons. As we can see that each electronegative element is attracting the electrons towards itself, so the net dipole moment for this molecule is 0. For methane, we have carbon bonded to 4 hydrogen atoms and the structure is tetrahedral. There is no lone pair of electron present on the carbon atom and the bond angle is 109. Again, the overall dipole moment for this molecule is also 0. Third is phosphorus pentafluoride. Phosphorus pentafluoride, the structure is, we have 3 fluorine atoms surrounding the phosphorus in trigonal form and 2 like this, that one is on top and one is at bottom. So the bond angle between these 3 is 120 degree and the bond angle is 90 degree for this one. Now you can see that phosphorus is surrounded from all sides by fluorine atoms, so net dipole moment is also 0. So the option for question 32 is A, as all are correct. Question 33. Carbon exists in several different forms. 2 of these forms are Buckminster fullerene and graphene. Buckminster fullerene is a fullerene allotrope of carbon. Which statements about Buckminster fullerene and graphene are correct? Number 1. Both have delocalized electrons. Now in Buckminster fullerene and graphene, carbon makes 3 bonds. And the 4th bond is a pi bond. And because of the presence of that pi bond, the electrons are actually delocalized. Second part says Buckminster fullerene has a giant molecular structure. No, this is not correct because Buckminster fullerene is made up of 60 atoms only. So it is not a giant molecular structure, it is a simple molecular structure. Third one says the carbon atoms in graphene forms a tetrahedral lattice. As we know that the carbon is making just 3 sigma bonds, so it is not tetrahedral, so this is also wrong. So the only option that is correct is 1, so the answer is D. Question 34. Carbon monoxide burns readily in oxygen to form carbon dioxide. What does this information suggest? Number 1. The +4 oxidation state of carbon is more stable than the +2 state. We know that in carbon dioxide, carbon exists in +4 form, while in carbon monoxide, carbon exists in +2 form. So this is correct. That's why carbon monoxide always forms carbon dioxide. Number 2, the standard enthalpy change of formation of carbon dioxide is more negative than the standard enthalpy change of formation of carbon monoxide. This actually means that carbon dioxide is more stable compound when compared with carbon monoxide. The compound having more negative enthalpy change of formation is always more stable. So this is also correct. Three, the value of equilibrium constant for the reaction is likely to be high. Now equilibrium constant is actually Kc, and Kc depends on the concentration of product to the concentration of reactants. As this reaction is moving in the forward direction, so it means that the concentration of carbon dioxide will be higher. So when carbon dioxide is higher, it means that Kc value will also be high. So this is also correct. So all options are correct. So the answer is part A. Question 35. The catalytic converters fitted to cars remove pollutants from the exhaust gases. Some of the reactions that occur involve oxygen which comes from the air. Which pollutants in the exhaust gases will react with oxygen on the surface of the catalytic converter? Now we know that in catalytic converter basically carbon monoxide and nitrogen dioxide is converted into carbon dioxide and nitrogen gas. So NO2 reacts with carbon monoxide, actually it does not react with oxygen. The question says which pollutant will react with oxygen. Second is unburned fuel. The unburned fuel again reacts with oxygen to burn properly into carbon dioxide and water vapors. This is correct. Third is carbon monoxide. It also reacts with oxygen to form carbon dioxide. So this is also correct. So part 2 and 3 are correct and the answer is C. Question 36. Chlorine reacts with sodium hydroxide in two different ways depending upon the temperature. So there is a temperature difference between the reaction 1 and reaction 2. Which statements about these reactions are correct? Number 1. Reaction 2 requires higher temperature than the reaction 1. Let's see what type of reaction is this one. Actually these reactions are the disproportionation reaction of chlorine. Disproportionation means self-oxidation and reduction. So in these reactions, chlorine is oxidized and reduced at the same time. So it says reaction 2 requires a higher temperature than reaction 1. This is correct because in reaction 2, chlorate ion is being produced, which is produced from hot alkali. So reaction 1 occurs in cold alkali. While reaction 2 occurs in hot alkali. Part 2. The products of reaction 1 show chlorine in two different oxidation states. Now, this chlorine is -1 and this one is. We can find the oxidation state of this chlorine. ClO, overall charge is minus. We know that oxygen is -2 and overall charge is -1. So chlorine -2 is equal to -1. Chlorine is equal to +2 -1. Chlorine is equal to +1. So chlorine is actually +1 in this compound. So there are two different oxidation states. So this is also true. Third one says the product of reaction 2 shows oxygen in two different oxidation states. Now we can find the oxidation state of oxygen. In water, the oxidation state of oxygen is -2. And in chlorate ion, ClO3-, the oxidation state of oxygen is still -2. It is not changed, so therefore this one is incorrect. So the answer is B. Question 37. In which of these reactions in the organic compound oxidized by the given reagent? So we have to see whether the organic compound is being oxidized or not. First one is aldehyde, second is also an aldehyde, third is also an aldehyde. So in first one, the aldehyde reacts with hydrogen cyanide. It is CH3 C double bond OH. It reacts with HCN, and the product will be hydroxynitrile. So we can see that hydrogen is being added to the reactant, so oxidation haven't taken place. So this is not true. Second is Tollens reagent. Tollens reagent actually consists of silver positive ion, and Tollens reagent gives positive result with aldehyde. It means that Tollens reagent can oxidize aldehyde to carboxylate ion, whether itself it is reduced to silver. So therefore true is correct. The third one says Fehling's reagent. In Fehling's reagent, copper plus 2 is present. Copper plus 2 is reduced to copper plus 1, and aldehyde is converted into carboxylate ion. So therefore Fehling's reagent also oxidizes aldehyde. So part 2 and part 3 are correct. So therefore the answer is C. Question 38. When the apparatus is set up as shown, an orange precipitate forms in test tube Z. So we have two different test tubes. In first test tube we have acidified potassium dichromate, which is a powerful oxidizing agent. In second test tube we have 2,4-dinitrophenylhydrazine or 2,4-DNPH. And we know that 2,4-DNPH actually it gives positive result with carbonyl carbon of aldehyde and of ketone. What could compound Q be? Number 1, this is an alcohol. We can see that this carbon is only attached to one other carbon atom, so it is primary alcohol. Now when passed through test tube Y, primary alcohol converts into aldehyde, and then when passed through the second test tube it gives positive result with 2,4-DNPH because of the presence of carbonyl carbon. Second one is also alcohol, but in this one OH is attached to the second carbon atom, so this is secondary alcohol. Now secondary alcohol oxidizes in the presence of potassium dichromate to form ketone, and ketone also gives positive result with 2,4-DNPH. Third one is alcohol in which carbon is attached to 3 carbon atoms directly, so this one is tertiary alcohol. The oxidation of tertiary alcohol is not possible, so therefore it won't give positive result with 2,4-DNPH. So only two options are there, 1 and 2, so therefore the answer is B. Question 39. Chlorofluoroalkanes that diffuse into the stratosphere are broken down by UV radiation. Radicals are generated that cause depletion of ozone. What are these radicals? So we know that in chlorofluorocarbons or chlorofluoroalkanes, chlorine, fluorine and hydrogen is present. So therefore UV radiation can only break the bond between carbon and chlorine atom, and chlorine radical is generated. Now chlorine radical actually is very harmful for ozone, as it causes chain reaction and converts ozone to oxygen. So therefore chlorine radical is the main cause. The fluorine radicals are not produced because carbon-fluorine bond is stronger and it is not decomposed easily by UV radiation. Alkyl radicals are also harmless for ozone. So the only option is 1, so the answer is D. The last question, question 40. A mixture of 3 isomers of C2H2Cl2 is polymerized. Which sequence will be seen within the polymer chains? So let's first draw the monomer C2, H2 and Cl2. Another Cl. This is the first isomer. Okay, we can also write like this. CH2, Cl2, or we can also draw the trans isomer of this one, CHCl, double bond CClH. Now these are the 3 types of isomers that are possible for C2H2Cl2. Now let's see what product is formed when they polymerize. Now we can see that in polymerization, if these 2 carbon come closer together, then this one is formed. If this is the part of polymer chain, then 2 is formed. And for 3, we can see if these 2 carbon atoms join together in the polymer chain, then 3 is formed. So it means all 3 sequences are possible, so therefore the answer is A. Thank you for watching. I hope this video was useful. If it is, then please drop a like and subscribe to this channel for more upcoming videos. See you in the next one. Till then, stay happy and keep smiling.